Imagine a star that has been silently moving across our sky for over a century, invisible to the naked eye, yet traveling faster than any other star we can observe. Barnard's star, a small, dim red dwarf, is just a short distance away. For decades, astronomers have wondered if it harbors secrets. And now, thanks to a recent discovery, they have confirmed that it does. Orbiting this nearby star, there is a planetary rocky world. How could this world remain hidden from our eyes for over a century? What does this mean for our search for life, and how might it affect the future of exoplanet research? The implications could be far-reaching. Join us as we begin our discussion. Barnard's star is located about 6 light-years away from Earth, making it one of our closest neighbors in the galaxy, second only to the Alpha Centauri system. Unlike Alpha Centauri, which is a complex multi-star system, Barnard's star stands alone. It belongs to the category of red dwarfs, one of the most common types of stars in our galaxy. Despite such abundance, red dwarfs are notoriously difficult to observe directly due to their relatively low brightness. For example, Barnard's star has only 16% of the Sun's mass and less than 0.4% of its luminosity, making it invisible to the naked eye. Naturally, the physical characteristics of Barnard's star distinguish it from its larger and hotter counterparts. With a surface temperature of about 400 degrees Fahrenheit, compared to 900 degrees Fahrenheit observed on the surface of the Sun, Barnard's star mostly emits infrared radiation. Its lower energy output means that any potential planets orbiting it would need to be much closer to the star to receive the same amount of energy as Earth does from the Sun. One of the most exciting features of Barnard's star is its unusual movement trajectory across the sky. With a proper motion of more than 10 arcseconds per year, it holds the title of the fastest moving star relative to the solar system. This movement is a result of its proximity and speed as it travels through the galaxy. Barnard's star moves at about 56 meters per second relative to our Sun. For astronomers, this fast travel has been a key reason why the star has been a subject of close observation for over a century. Its trajectory is mapped so well that astronomers can accurately predict its future movements. The star will continue approaching the solar system, coming as close as 3.75 light-years in about 10,000 years. The story of Barnard's star began in 1916 when American astronomer Edward Emerson Barnard first noticed its peculiar movement. This astronomer measured the celestial body shift against the backdrop of distant stars and realized that the object was moving faster than any other observed at the time. This discovery was groundbreaking, as it pointed to the presence of relatively nearby stars moving at significant speeds. For decades, Barnard's star has remained a prime target for observation, with its high proper motion allowing astronomers to study it in greater detail than many other stars. The first attempt to find planets around Barnard's star began in the 1960s, driven by its status as one of the closest stars to Earth. Early searches focused on detecting large gas giant planets like Jupiter or Saturn. However, the available methods at the time, particularly astrometry, were far from perfect. Astrometry involves measuring tiny changes in a star's position caused by the gravitational pull of orbiting planets. The challenge was to observe the star's wobble, triggered by the gravitational pull of an invisible planet. But since the technology was still in its early stages, these measurements were prone to significant errors. Despite these limitations, in the 1960s and 70s, astronomers such as Peter van der Kamp claimed to have detected planets around Barnard star using astrometric methods. Van der Kamp's team believed they had discovered a gas giant with a mass several times greater than Jupiter's. This idea generated excitement, as it would have provided insight into planet formation around red dwarfs, which were believed to be less likely to host large planets. However, subsequent research cast doubt on these findings. As observational techniques improved, it became clear that the initial claims were based on overly inaccurate data. The wobble detected in the star's movement was not caused by a planet, but most likely by instrument error or other sources of noise. By the 1980s, the idea of a massive planet orbiting Barnard's star was largely debunked, and astronomers had to reconsider the methods over the next few decades. Astronomers developed more sophisticated tools, such as the radial velocity method, which allowed them to indirectly detect planets by observing shifts in the star's light spectrum. This method, using the movement of the star closer to or further from Earth, proved much more reliable. By the 1990s, these new methods replaced astrometry as the primary tool for searching for planets in star systems. However, the absence of planets around Barnard's star continued to puzzle scientific minds, especially since other red dwarfs, like Proxima Centauri, had been found to host planets, including potentially habitable ones. Barnard's star, on the other hand, seemed to defy expectations. A breakthrough occurred in the late 2010s when advancements in technology, particularly the development of more sensitive spectrographs, allowed astronomers to take a fresh look at the star. In 2018, researchers once again announced they had detected a super-Earth orbiting Barnard's star, reigniting interest in this system. The discovery was made using a combination of radial velocity data and other advanced techniques, confirming that while there were no gas giants, small rocky planets could indeed be present. A planet believed to be slightly larger and with a mass greater than Earth was detected using the radial velocity method, which measures shifts in the star's light caused by the gravitational pull of orbiting planets. This method tracks the wobble of the star by observing